Hey, what's going on, guys? Again here. In this video we're going to be printing bitboards to the console in a human readable way. So last video we ended up with defining three absolute essential macros allowing us to get bits, set bits and pop bits from a given bitboard at the given index. And also we've defined the U64 kind of a variable type that would be automatically replaced with the unsigned long by the C preprocessor. So let's actually start with definition of our print bitboard function here. So I create the void function called print bitboard, and this would be taking the U64 bitboard as its argument here. So yeah, let me just make a little bit more space here. So the very first thing we need to do here, we need to loop over board ranks, okay, and also we need to so here we need to just say like for int rank equals to 0, rank is less than 8, and rank plus plus. And now we need to do the same but for files. So okay, just copy and the same for the files. So int file equals 0, file is less than 8, and file plus plus eventually. Okay, so here we loop over board files. Okay, so we also want to print the new line after every single rank basically, and also we want to print ranks in case if no file, or other words file is equal to 0. So in this case we want to print f, and let's give a couple of spaces, and 8 minus rank to print them to map the ranks appropriately. Okay, so I guess yeah, and just as the placeholder, for now I just want to print f this zeros here to just as the placeholder for our bits that would be represented on this bitboard. So I just want to open the terminal in the current working directory. Now I need to compile and run the code. In order to do this, I need to say gcc bitboard.c, which is the file name, -o, create an output file called bitboard, and if it compiles, I just want to run this like this. So nothing happens because we didn't yet call our print bitboard function, so I will do this now. So print bitboard, okay, and also just to bear in mind that we need to define some sort of a bitboard. So let's create a U64 bitboard called, well, let's call this white bonds, and this would be equal to 0 unsigned long like this. So this unsigned long to make sure that the constant of 0 consists of up to 64 bits, just the safe way of defining U64 variables here. And we just pass our white pawns to our print bitboard function. Obviously we're not gonna be working with this for now, because for now I just want to prettify the layout. Okay, it's almost like that. So let's print f a new line here, and also would like to print files, and A, B, C, D, E, F, G, H, and a couple of new lines after. Okay, just shift them slightly. Oh, it's too much. Okay, yeah, now this is more or less okay. So okay, and now here, instead of this 0 placeholder, we actually want to print print bit at the current square, let's call it like this. So also we want to define our square, so init square, and in order to get the square from this nested for loops, we need simply to say like rank multiplied by 8, which is the width of our chessboard, and simply plus file like this. Okay, and if we just print our square for now, just again as a placeholder, so just to give you an idea, square. So here are the indexes we're looping over, and this indexes would be used as the bit shifts as an index to shift the bit at the number of this index here within our get and actually set and pop bit as well, but here. So what we're doing in this macro, we're taking the unsigned long constant equals to 1 and then shifting it to the left the number of times like this index variable is equal to. So this index, so here this index would take the value of the square, and respectively this one would be shifted to the left the number of times of what the square actually equal now. If you don't understand this, please watch the previous video in this BITBOARD series that regards to the bit manipulation techniques, where I've been explaining these 3 simple macros for about 40 minutes. So I hope that would be really clear after you watch that, if you don't understand what's happening. For now, I just want to say that here we want to get bit, and I'm passing the BITBOARD we're currently working with, and I'm passing the square as the second argument to serve as an index. And now we want to say, now I'm using the ternary operator to like as a shortcut for if statement. So if this expression returns true, that means that bit is available at the current index or at the current square, and in this case we want to print 1. Otherwise, I'm sorry guys, we want to print 0. So now it should be all the zeros because we didn't yet set up any sort of bits here. So let's try to set some bits, and now you see like bits are appearing. But obviously setting the bits in this decimal format doesn't really tell you much, so it would be much more appropriate to actually be able to set the bits using the human readable coordinates like E2, E4, and so on. So in order to implement this, let me just we can actually leave this at the moment. So I just want to print some I just want to implement some debugging stuff here. So just say for int I is equal to 8 and I is greater than 1, I minus minus, and I just want to print, so just in order to save time on typing this by hands, you will now understand what am I doing here. So I just want to print like A, B, C, D, E, F, G, H, and this decimal formatting after each one, and the new line on the very end, and here I'll use this I, and it should print, or hold on a sec, is this really, yeah, it should be like, oh my god, what have I done, something, oh my god, what's going on here? Hold on a sec. Okay. Hold on. I have no idea. Like, it should get. Well, this part is correct. A8, and then what's going on here? This is so weird. Okay, I'm sorry guys. Just I swear I've been doing this before recording this video, and not even for one time. I'm just really wondering, like, what the hell is going on? Oh man. what am I doing? Yeah, I just need to specify this 8 times. I'm sorry, I'm so sorry. So 1 2 3 4 5 5 6 7 8. I'm really sorry. Oh my god, how could I forget that? So this is the exact mapping I've been talking about, where we have our squares. So if I now just define squares and say enum equals to, and I just use this values here. I'll probably, I should make a space before. Okay, this like. So from now on, in theory, we should be able to use this the squares to actually initialize our board. Well, even though it won't be specified on sign lon anymore, but still. So yeah, let's just specify. Yeah, no, that's not like. So we specify this. So here we just define white pawns bitboard, and here set white pawn on, and well, let's say E2. Okay, square. So I'm using my set bit macro, and I'm passing the white pawns, and I'm also passing, what else do I need to pass here? The E2 square. And in theory, so print bitboard, so in theory it should make this bit equals to 1. Okay, so let me just get rid of this stuff for a while. Okay, what? E2 undeclared? You kidding me, man? What do you mean it is undeclared? It should be. Oh, not equals. What have I done? Colon here. Oh, just forgot to put the commas here. Okay, so now we have this coordinate of E2 being set up with a white pawn. So this bit represents the white pawn, as far as we're dealing with white pawn's bitboards. So now, just to give you an idea of how else this could have been done, basically. So we can set the pawns. Well, obviously nobody's doing this in this sort of way, but I just want to show you. I just want to show you the concept, so it would be clear, like, how to deal with this bitboard initialization. So let's start from A2, then go into B2, C2, D2, E2, F2, and G2, and H2. And now all the white pawns should get set up here. Yeah, so here is the bitboard with the white pawns initialized to the starting position. This is how it looks like. So quite pretty clear, I believe. And also it's really pretty printed. It's pretty printed quite pretty nicely, so it's much better compared to when we were printing this bitboard as the binary string, but at the same time we did this in one line. So now this is 8 to 8 squares are way more readable, I believe. So a few more things until we end this video. So here I just can print off. So this is white pawns bitboard. Okay. Okay, probably like this. Okay, so white pawns bitboard, and this is kind of it. So yeah, and obviously if you want to create another bitboard, you just make another bitboard here and just call it respectively white knights, and you just can set the bits to the appropriate squares like G1 and B1 and so on. So I'm not going to be doing this because I think it's quite pretty self-explanatory, clear within the pawns. The very last thing I would like to show you is probably, so let's here after this sort of stuff here, or even no, it's just fine. I want to print bitboard as decimal number, just to give you an idea of how it looks like in decimal, basically. So I just want to print f, and here I say bitboard and in decimal representation. So a long decimal and the bitboard like this. Sorry. Oh, bitboard like this. Okay, and let's also give it acute layout. Okay, we don't need this, but here. Okay, now this is good. Probably let's even. Okay, I just get rid of this in decimal representation. It's quite pretty self-explanatory itself. So just want you guys to visually compare this to things. So if we have a look at white pawns starting position bitboard, this is the exact unsigned long integer number that represents the starting position of white bitboards. Well, assuming board NANs and things like that, but nevertheless. So this is how it looks like. And by the way, another interesting thing here that we can actually use this number to initialize all the white pawns in one round. So instead of doing this with a set bit here, we can also do this with specifying the bitboards equals to this number. So if I just actually get rid of this part and I just simply copy this number here, so copy, so white pawns would be equal to this number, unsigned long, and in theory, yeah, I hope in practice as well, it should give absolutely the same value here. So this is kind of it, guys. So here we have the binary representation that makes perfect sense in terms of we can visually see where our white pawns are located, and here respectively we have like this decimal representation of the white pawns bitboard. So there is nothing more to say within this video, I believe, so I guess this is it from my side. And in the next video we're gonna be printing, we're gonna be initializing all the bitboards. Well, maybe it's not the point to initialize all the bitboards basically, but it's just a matter of mapping, not mapping, but the matter of taking all the 12 bitboards into one. So we're going to be printing the board, like overall board, just like print the chessboard position. That's the topic of the next video. And assuming that the chessboard position consists of up to 12 bitboards, it would be a little bit of a challenge to actually unite them all in one and print and respectively, instead of zeros and ones, we would be printing the piece characters, like the standard notation for piece characters, like ASCII characters. So this letters, first letters like P, N, P for pawn, N for knight, B for bishop, and so on and so on. So I will deeply explain this within the next video, and for now I think this is quite pretty enough here. So I hope you learned something interesting out of following this video, guys, if you did actually. So bitboards are not that monsters that you could have imagined they are. If you understand the basics, the floor of the bit manipulations, the bitboards become very easy, interesting, and addicting thing to consider, and it's incredibly interesting to work with them, at least to my own, at least in my own opinion. So I'm not going to be wasting your time anymore, or taking your time anymore. So thanks for watching, and see you next video. Take care, guys.